All right, 1.4 is going to be operations on real numbers and evaluating square roots. All right, so let's look at adding, subtracting, multiplying, and dividing real numbers first. Yep. Okay, let's do multiplying then. All right, so when it comes to multiplying and dividing, we'll do dividing next. They're just we just use symbols to emphasize the rules that come into play. We're talking about multiplying, dividing real numbers. So two positives, multiplying two positives will result in a positive number. Multiplying two negatives will result in a positive number. So if you have same signs, the two numbers, if you multiply them together, they'll give you a positive result. Different signs will give you a negative result. So plus, minus, multiplying those together give you negative. Then negative times positive will also give you negative. So when we go over here to what I've written just for scenarios emphasizing what we got going on the left. Positive 2 times positive 3 will be positive 6. Negative 2 times negative 3 will also give you positive 6. Positive 2 times negative 3 will be negative 6, and then negative 2 times positive 3 will be negative 6. All right. Questions on multiplying, the signs, the results, anything. All right, scrolling up. Dividing is the same thing. Let me scroll up a little more. All right, so dividing is the same thing. Two of the same sign will result in a positive answer. Different signs will give you a negative answer. So positive 18 divided by positive 2 will be positive 9. Negative 18 divided by negative 2 will also give you positive 9. Positive 18 divided by negative 2 is going to be negative 9. Negative 18 divided by positive 2 will also yield negative 9. All right. Any questions on multiplying, dividing? Let's do it like this. Let's add.
Daddy, water, please.
All right. So when it comes to adding, I always say think about your money. Think about your money. Let me see. Somebody sent something in the chat. When my dinner comes, I'm going to turn the video off. Okay. It's all good. It's all good. Keep your mic off too. We won't hear you smacking. It's all good though. So when adding, if you think about your money, you should be in a good place. So if you have same signs, what you're going to do is add the numbers and then keep the sign that you're dealing with. So these first two, notice both of them are positive. If I have $5 in my account and I add $2 to my account, then of course I have $7 in my account. I add those two and keep the sign. Everything was positive. The result will still be positive. Negative, if both of them are negative, let's say I'm negative $5 in debt or in the hole. If I get a $2 charge, it's not going to go positive, right? It's going to go further in debt. So that would be -7. So same signs, you add them and you keep the sign. All right. Now, if you have different signs, you're going to subtract them and then you keep the sign of the greater. So if I have a +5 plus -2, $5 in my account, go get some French fries for $2. I'm going to be left with $3 in my account. The $5 was greater, it was positive, so my result is positive. -5 plus a +2. So if I'm -$5 in the hole and I add $2, that's a positive effect. I add $2 in my account because I'm trying to get out of the red. I'm still going to be -$3 in the hole. So if you think about your money, then it should be more applicable to you. So when you talk about different signs, you go ahead and subtract them, and then whichever number is greater, you keep that sign. All right. Questions on that before we go to subtraction? Good. Okay. And then some of the stuff, if you haven't seen it in a while, the more you do it, the more it becomes, natural to you, and you'll get more comfortable with it, I should say. All right, so for subtraction, we're going to convert to addition and use addition rules. And the more you do this, the less you have to write out stuff and the less you think about converting to addition. But it would help us when we go through the processing of what is right and what is wrong. So we have 4 minus 3. We know 4 minus 3 is 1. But in algebra, I do want you to get used to the idea that a minus 3 and a negative 3 are the same thing. If you can make sure you transition with that thought, it'll make things easier for you when you start dealing with your algebraic scenarios. Negative 3 and minus 3 are the exact same thing. 4 plus negative 3 and 4 minus 3 will still give you positive 1. So something like that helps when we look at that second example, because a lot of times people look at negative 4 minus 3 and then they want to write negative 1 as the result, because we're so used to saying take away. You know, we do minus and we want to say take away 3. So in your mind, you say, okay, if I take away 3 from negative 4, that leaves me with negative 1. But this is negative 4 plus negative 3. So remember, we just finished looking at, hey, if I'm adding two numbers that have the same sign, I should actually add them and keep that sign. So my answer here would actually be negative 7. All right. So don't forget, both of them are negative. And if you have two negative numbers that you're adding together, it'll put you further, deeper in debt or deeper in negative. So negative 4 minus 3 will give you negative 7. Now for the next two, you don't have a choice but to convert into addition, because a negative to a negative turns positive. Let me do that. So negative to negative turns positive. So this is 4 plus 3, which is positive 7. And this negative 4 plus 3, which will give us the negative 1. All right. Questions on adding, subtracting, multiplying, dividing, sign numbers, just your foundational rules.
Are you gonna put each lesson in the video like you did last time? Because I had a hard time logging in and I missed the first two with the addition. With the multiplying and dividing.
Oh, yeah. Whenever I do a lecture, I record them and then I'll create a YouTube video for you guys.
Right.
Yep. Mm-hmm. All right. And if you want, before we leave, I can scroll back up, and let you copy that if you want. It's not a big deal.
Yeah, because I wanted to keep everything in order. That's the only way I can understand it.
Yeah. So don't let me forget. I'll make sure you get that. All right. So let's do a few examples. Those are examples, just doing a few more to reiterate what we just finished talking about. I already wrote it down. I'm gonna scroll back up. I'm just gonna write a whole bunch of them down, and we'll just do examples. Get a couple division in there, and then we'll go ahead and do a few. Then we talk about powers. Didn't we do powers last class? Powers, and I think we did. I think we did. Didn't we do those last class? Square, taking the square. Anybody?
Yeah, we did.
Yeah, I thought so. Okay, I won't revisit that. All right, good. So let's do that. I think I saw somebody say something in the chat. Oh, okay. Yes. All right, so let's just do a few just to reiterate or reemphasize those rules that we just finished talking about. So we have -3 plus -11. Remember, same signs, you're going to add them and keep the sign that we're dealing with. So -3 plus -11 is -14. The next one, we had -1/4 plus 1/2. Don't forget, we have different signs. You're going to subtract and keep the greater of the two. But in order for us to add fractions, remember, we need a common denominator. So that's going to be 4, because 4 can divide into itself, and of course 2 can divide into 4. So in order to change 1/2 into a fraction that has a denominator of 4, we'll multiply top and bottom by 2. -4, and that's 2/4. See somebody in the chat. -4 from 1. All right. Sorry, I was answering a classmate. So now we have -1/4 plus 2/4, and that will be 1/4. So you subtract them and then keep the sign of the greater. So -10 plus 15, same type of deal. We have two different signs. We're going to subtract them, keep the sign of the greater. So that'll be a +5 as a result. -8 minus -1. Don't forget, negative to a negative turns positive. So that's -8 plus 1, which would be a -7. All right. 2 minus 7 is the same thing as 2 plus -7. So that result would be a -5. You're adding two different signs. Subtracting means we will subtract and keep the sign of the greater. And of course, if I, scrolling too fast or moving too fast, feel free to slow me down. For the next one, we have 11 plus 2 minus 7. So take your time. You don't have to add all three of them at the same time unless you just got it like that. Be nice with it. We have 11 plus 2. That'll be 13. And now we do 13 minus 7, which is 6.
How come you didn't change the sign when you did the 13 minus 7 and make that sign a -7?
Well, it's the hopes that eventually you guys will see that and won't have to always write it out. So I'm trying to condition your thoughts to, at
Oh,
first I might write all the steps, and then eventually I may not write every single step, and then, you know what I mean? So I'm
yeah, I
just
got.
trying to condition your mind to say it. And so I guess it worked because you saw it.
Yeah, I see it.
So yep. So next one, -8 times -7. So negative times a negative is positive. That goes back to the same thought process right here. Negative to negative is positive. That's multiplication. So this result would be 56. All right. Same thing happens with this next one. Notice we have 7 times 1 times -2 times -3. So once again, take your time. You don't have to multiply them all at the same time. 7 times 1 is 7. Now, and we'll see, I believe in one of these sections, we'll get to properties. Now, multiplication is commutative, so is addition. So if you want to do 7 times -2, you could, or if you want to do -2 times -3 first, you could. It doesn't matter, you still get the same result. I'll just go ahead and just be a little different. So I'll jump over here, -2 times -3. would be a positive 6. And then 7 times 6 would be 42. Now, if you wanted, you could have done 7 times negative 2. That would have been negative 14. Then negative 14 times negative 3 would give you a positive 42. So either way, no matter what order, you will still get the same result. All right. Anybody see what that next one would be? Anybody want to throw that out there? Anybody? Don't work too hard. Answer is 0. So, yep. So whenever you have a string like that, it always pays attention to look ahead a little bit. So remember, when it comes to 0, anytime you multiply anything to 0, the result will be 0. So you can do 8 times 2, that'll give you 16 times 11. That will give you a number, but once they get here, it'll still go to 0. Then the rest would be 0 as well. So, yep. Answer just 0. All right. What's that? Okay. Next one, negative 9 over negative 3. It's going to be positive 3. Negative to negative turns positive. Positive 20 over negative 4 is negative 5. Negative 1 over 10 divided by negative 2 over 5. Don't forget, whenever dividing fractions, you have to multiply by the reciprocal. So that means you'll flip the fraction. Now, if you'd like to multiply across, you could. Negative 1 times negative 5 is a positive 5. Down bottom, 10 times 2 is 20. And then also we can reduce this because 20 is 4 times 5. 5s will cancel, leave you with 1 in the numerator, and that result would be 1 over 4. All right. Last one, try not to get caught up on that. 8 divided by 0 is undefined. It's not even a number. So always remember 0 in your denominator is bad. Do not want 0 in your denominator. Now 0 over 8 though is 0. But 0 in your denominator, 8 over 0 would be undefined. Anything over 0 is undefined. All right, any questions before we look at square roots? In the same section, we haven't left the section. This is the last thing in the section. All right. So square root. Let me see what's a good way of writing this. All right, so when we look at square root, you're asking yourself what number times itself twice will give you the number under the radical. So when we look at this, this is called the radical. This is actually called the radicand. Most people don't talk about it, but that's why I didn't use it in our question. But the number under the radical is your radicand. So you want to know what number times itself twice will give you the number, give you the radicand or the number under the radical. So we're looking at the square root of 9. That's going to be 3. And that's the foundation of what you'll do when it comes to square roots. So let's throw some more up. I'm going to go 121, 44. All right, so square root of 144 is 12, because 12 times 12, gives us 144. Square root of 121, 11. Square root of 49, 7. And the square roots of 36. Be careful here, because there's no number you can multiply to itself twice that will give you a negative value. So not a real number. In mathematics, not sure if you've dealt with them before. There is something that we have, which is what we call imaginary numbers. That's what taking the square root of a negative would do to you, or do for you, not do to you, but do for you. But all you guys are held responsible for is writing not a real number. So if you see a negative under the radical, the answer is not a real number. Now be careful. Not sure if you're going to see this, but you just may. Now this right here, the result is going to be -6, because the negative is sitting on the outside of the radical, is never affected by the radical. So make sure you're okay with negative placement in reference to your radical. Is everybody okay with that? Make sure we're good. And then here, square root of 1 over square root of 4, you can look at it that way, taking the square root of the numerator and denominator individually. Square root of 1 is 1, because 1 times 1 is 1. Then square root of 4 is 2. All right. Questions. All right, so let's look at 1.5. All right, properties of real numbers. All right, so your commutative property. I guess I should have wrote property. Commutative property just says that A plus B and B plus A are the same. A times B and B times A is the same as well. And notice they only mention addition and multiplication. That's because, as we already saw, any subtraction can be rewritten as addition, and really any division can be rewritten as multiplication. So to shorten up notation, they just discuss addition and multiplication practices. And so, yep. So example, 4 plus 5 and 5 plus 4 will still give you 9. 8 times 3, 3 times 8 will still give you 24. All right. Associative should be next. Let's make sure. Yep. Oh, somebody in the chat. Oh, okay. Yeah, you're fine. You're fine. Everybody eating dinner, ain't nobody trying to share. It's all good. All right, social property. Let's see, A plus B. Yeah. All right, so social property, A plus B plus C. So if you're adding more than just two terms or two numbers, doesn't matter which order you add them in. Same thing with multiplication. Doesn't matter which order you multiply in, you'll still get the same result if they're all multiplication or if they're all addition, or written in the form of multiplication and written in the form of addition. So, example of that. Let's say if I do. All right, 1 plus 2 plus 3. 1 plus 2, if I do that first, that'll be 3 plus 3, which will give me 6. Then 2 plus 3, do that first. 1 plus 5 will still give me 6. So that's all they're saying is that it doesn't matter which order you were to add or multiply in, still get the same result. And this is going to help us when we go into simplifying our expressions, combining like terms and all that good stuff like that. Let's see, that might be in 2. Yeah, I'll wait till I get there. All right, let's go to distributive. So if you have A times this quantity of B plus C, you will be able to distribute A over the parentheses or into each term in the parentheses. So that'd be AB plus AC. Same thing if there was a minus sign there, it would just be AB minus AC. So if I had 3 times the quantity of X plus 2Y minus 5Z, I can distribute that 3 to each term, and that would be multiplication. So that would be 3X plus 6Y minus 15Z. If I have a negative sitting out front of a parentheses, that minus sign needs to be distributed in the same fashion as if that was a regular number. And it would just change the sign of each. So negative applied to a positive 4 would just be negative 4A. Negative to a negative would be a positive 9B. And then that would be minus 12 in the back. So a minus sign sitting in front of a parentheses will change each one of the signs that are in, each one of the signs of each term in the parentheses. Do at least one more. Let's see one with a fraction. All right, cool. All right, so here we want to do the same thing, and be careful here with your distribution. That 1/2 will only be applied to the terms that are in the parentheses. That 10 in the back will not be affected. So you're talking about 6/2 plus 14/2 plus 10. 6/2 is 3 plus 7 plus 10. And this is going to help us to segue into the next section. We have what we call like terms. We have these two numbers in the back that we can add together. And that 7 plus 10 would be 17. And this will be our most simplified expression. Cannot add the 17 and the 3x together because we don't know what x is, or we don't know what x means. Better saying we don't know what x is versus what it means. All right. Two more properties I just saw before we leave this section. Any questions? Any questions? Everybody good?
I'm not understanding what happened to the one when you did the half on the outside. What made it 6x/2? Like, I'm confused about that part.
Oh, 1/2 times 6 is the same thing as doing 6/1. And so from there, you just multiply across.
Oh, okay.
Yeah, and then that'll just be 6/2. All right. All right. Everybody cool? Everybody cool? Straight. All right. So looking at our identities for addition and multiplication. Let's see. Yep. All right. So your identities for addition and multiplication, a plus 0 or 0 plus a will still give you a. And then a times 1 or 1 times a will still give you a. So in other words, no matter what number you use, a just represents any number. 5 plus 0 is going to be 5. And then 5 times 1 is also 5. So that's all it's saying. No matter what number you add to 0, it will be itself. No matter what number you multiply to 1, it will be itself. All right, so your inverses, any number plus its negative, or in other words, plus its opposite, will give you 0. And then any number times its inverse, that's what 1/a represents, its inverse, will give you 1. So just an example of how that works, 5 plus -5 is 0. But then we talk about 5 times 1/5, And that's similar to what we did with that 6 and the 1/2. You look at that 5 as being 5 over 1, multiply across, that's 5 over 5, and then 5 divided by 5 is 1. So, whether you write out all that or not, that's just how you would process it. All right, questions on properties, questions on the properties. So that's it for chapter 1. I know some of y'all are ready for a test. We'll just hold on for a second before we get there. Let's look at chapter 2 first. Let's see how many sections y'all want to do today. Let me see. We got 2-1, 2-2. So y'all are trying to see 2-1, 2-2, 3-4. Okay, so we'll do 2-1, maybe because 2-1 is short. Then probably just do 2-2 and then be done with it for today. Okay, that still won't take us to 10. I guess I can let y'all go though. Y'all are tripping. All right, so let's go 2-1. Simplifying. So simplifying algebraic expressions. Yeah, I got lazy on the algebraic, but that's what it is for us. So we're gonna start off talking about like terms versus unlike terms. So your like terms are gonna be terms that you can add and subtract from each other with no problems. They have to have the same variables, same amount of variables, same exponent on your variables in order for you to be able to do so. So 3x and 5x would be like terms. Negative 10xy, 8xy. All right, so 3x and 5x are like terms. Negative 10x, 8xy are like terms. We have 21x squared y, negative 100x squared y. And even the numbers with no variables at all, they're called constants, 7 and 11. They will be like terms. You can add them and subtract them from each other with no problem. So if anything changes in your variables, anything different, you cannot add them or subtract them. So 3x and 5 would be unlike terms. Negative 10xy. Let's go 10x and 8y. They're unlike. Here, xy. And then if the other one has x squared y, they will still be considered unlike, even though they both have xy involved. So if anything's different in your variables, you cannot add them or subtract them from each other.
I have a question.
Yep.
So when you're talking about anything being different with your variables, why is the negative not included?
Say the last part again. Y is what?
So when you're talking about like any different, like in your variables, why is negative from positive not included in that?
No, they're not, because what we're going to do is we're just going to add the front number according to our signs. So, yeah. So just a few similar scenarios, but just to reemphasize what we can and cannot add. All of them are separate. Um, all right. So 5x plus 3x, that would be 8x. 5x plus 3y is in lowest terms. Cannot add them. 5x squared plus 3x squared would be 8x squared. Notice the power of 2 stays the same. All you're doing is adding the numbers that are in front of your variables. That you call your coefficients. Then we have 5x squared plus 3x squared is already in lowest terms. Just write an LT for that. 5x plus 3 already in lowest terms. Can't add that either. So before we add a little more to our phrases, questions on like terms. All right. So directions would just be simplify. Let's see. Yeah. All right, so it's good enough for right now. All right, so 2x plus 5 plus 3x minus 2. All you're going to do is combine your like terms. So the 2x and the 3x, 5x, and then 2 and negative 5 and negative 2 would be a positive 3. And that would be it. All right, next one, negative 5a, positive a. Don't forget that in front of this a, there is a 1. Assume you know there's a 1 there. So really that's negative 5 and a positive 1, which would be negative 4. And then negative 3 and positive 7 is going to be a positive 4. All right, next one, distribute the 5. Just re-emphasizing distribution. That'll be 15x plus 10. Then in the next one, we have negative 2 that we're going to distribute. Then also don't forget what I mentioned about a negative being in front of the parentheses. That has to hit each term in the parentheses as well. And be careful with that. A lot of times people forget to give it to each term in the parentheses, and they'll just give it to the first term. And of course, you have at least one of your terms wrong if you don't distribute that negative throughout the parentheses. So that'll be a negative 8x minus 14 minus 3x plus 1. Combine your like terms, negative 8x, negative 3x, negative 11x, negative 14 plus 1, negative 13. questions? Any questions?
I don't understand how you got the second parentheses where it says minus the 3x minus 1.
Mm-hmm.
What is the negative representing itself on the outside?
Yeah, you can look at it as being a -1 if you like. But basically, the effect that a negative by itself has on terms is just that it changes the sign to the opposite sign. So before we had a +3, but now it's a -3. And before we had -1, but now it's a +1.
Oh, okay.
Yeah. So that's what a negative would do to your each term. All right. Any other questions? Everybody good? One last thing in this section. All right, so we're going to write the phrase as an algebraic expression. Let x represent the unknown number. Okay, looking at these first two. Twice a number plus 6. So whenever you're dealing with these, they're going to be key phrases or key words that let us know what operation to use. They already told us they want us to use x as far as our variable is concerned. If you're going to twice a number, that means multiply by 2. So you're talking about 2x and then plus 6. I think we're all cool with plus 6. So that twice number meant multiply by 2. All right. Next one, the difference of a number in 4 divided by 7. So difference is subtraction. So the difference of a number in 4, so that's x minus 4. Then it says divided by 7. So divide by 7. So just make sure, and then if you decide to use the other divisional sign, then make sure you do it this way, using parentheses. Let's do at least one more. Let's go with 5. All right, here 5 added to triple the sum of a number in 1. To triple the sum. Okay. All right. So we have 5 added to. So I think we're cool with that being 5 plus. Now, if we want to triple a sum, triple is multiply by 3. But we're not tripling a number, we're tripling the sum. Sum is addition. like that better. So if we want to triple the sum of a number and 1, we're going to multiply times 3x plus 1. So that's tripling or multiplying the sum of a number 1 by 3. All right, so let me see one thing. Checking my math lab for one thing real quick, guys. It's going to dictate what I do next. Where it go? Where it go? There we go. Okay, so, all right, so I think what I'll do, I'm battling, y'all. I'm battling. Because we've only been here for an hour, though. Now I don't want to let y'all go yet. And I know y'all hear my 3-year-old yelling in the background, right?
You better follow the boss's directions, man.
Say what now?
So you better follow the boss's direction.
I'm trying to ignore her, but she's making it real hard. All right, so let me see. So, because there are only 5 sections, let me get back to it. Where my stuff go? Go back to the main menu. There we go. So we're out of chapter 1 already. We know that, but there are only 4 sections in chapter 2. And then, got 4, 3, 6. Really don't have that much stuff to cover. All right, because what I'm trying to do is be cognizant of the content and the lateness of the night and the fact that we have to cover a certain amount of stuff. Okay. I'm going to map this thing out, and then I'll know for a fact what we can and cannot do. So I guess this is a good place to stop. Next class, we'll most definitely do 2, 2, 2, 3, and 2, 4, and be done with chapter 2. And then we'll have to talk about how we're going to do a test and all that stuff like that. But I guess this is okay. This place to stop. Look at her. Look, she up there smiling. Look at. All right. So yeah, because 2, 2, 2, 3, and 2, 4. I want to do those together, solving equations, and yeah, we'll do it like that. I just feel bad, man. Let y'all out like 2 hours early.
I got a question.
Yes, ma'am.
Do you have any practice on that? Because I haven't learned the math lab program yet. I know that it's only homework. So is there like a practice we can go over things before it get graded? I understand we can go back and always watch a video, but I like hand practice, like go over certain problems.
Well, you know, with my math lab, you get unlimited amount of tries, and it
Yeah,
doesn't. It,
I like that.
hmm.
I said I like that idea. When I went over the work, it was
Mm-hmm.
smooth because you get so many tries at one.
Mm-hmm. Yeah, so it won't affect your grade if you just go in there. I mean, if you do it 100 times, it won't affect your grade at all. Even if you get it right and you want to go and do the problem again, all you have to do is click similar exercise, and it'll give you another problem that's very similar to what you just did, even if you got it right.
Oh, similar exercise is not starting the problem over, it's practicing it.
Yeah. Uh-huh. Yep. And well, it's like this. Now, it will start that problem over. Well, I guess it depends on what your definition of starting that problem over is. Like if you have 5x, let's go here. I think you guys are still in my notes. Y'all still on my note screen, right? So if you have 5x plus 3 equal to 7 and you want to solve that, um, once you hit similar exercise, it'll do something like 2x plus 1 equal to 5. You know what I mean? It'll give you the same problem, but it'll change the
Yeah,
numbers.
I
So,
got
so that's what similar exercises do. So to give you all the practice that you want through my math lab. Now, if you just want some different ones, what you can do is, because we all have access to the e-text, if you go into the book and go to the end of that section, each section has a bunch of problems you can do. And so if you do any problems that are in the book and you don't know if you got it right or not, or maybe it's an even when it's not in the back, you can always ask, and I can go over it with you or tell you if you got it right or wrong or something like that. So
you.
that would be the other place you can get extra problems if you like.
And last question, once we
Mhm.
complete the video Zoom and we go back and do the work for the sections, we're done with it then, right? We don't have like no modules or nothing else left. Okay.
Nah, that's it. That's it. So in my math lab will be all your stuff and it's all listed out. And then what I'm going to do, what I need to do now before the next time I see you guys is create a test review and the actual test itself. And so then we can talk about how we're going to administer it. But at least the test review will be in there. You'll be able to see that. And I'll set that up the same way I do the homeworks, where you can do that unlimited amount of times. And I'm sorry, am I boring you? No, I'm just playing.
Oh, I'm really tired.
It's all good. Trust me. According to everybody's conversation, I think everybody's tired. Um, so yeah, so I'll create a test review, set it up just like a homework where you can do the unlimited amount of tries as well. They aren't mandatory. Just reiterating this, they aren't mandatory. But if you score 85 or better, then I will add 5 points to your actual test. So, but you don't have to do the test reviews unless if you don't want to.
What
All
do we
right.
do if we like pass everything except the tests?
Well now it depends on how low you go with that not fail. So basically, if you pass the test, if you have a 60 average, that's a D, but you did all of your homework, that'll bring your grade up to a C. So you go under 60, then we might have to have some discussion, might have to try to figure out some things for you. But I know that if you have a 60 average, which is really 1 point from F59 is supposed to be F. So if you have a 60 average and you did all of your homeworks, to the grades that we say you need to get on, you still will pass the class with a C. It'll bring your grade up. So I think you'd be good. I think you'd be all right. And then not to mention that the extra credit in the test reviews that can help you as well. So most of the time, if somebody failed my class, it's not because they did the work. It's really because they didn't do. You know, because most of the time the way I got it set up, you kind of buffered, wherein if you do everything you're supposed to do, you'll still pass the class with a decent grade. So.
Yeah, I'm not trying to just pass it though. That's the thing. Is like I need to get like a good grade and everything.
So if you want to get an A out of the course, the lowest your test average can be is an 85,
Okay.
because that'll put you right at like a 90 or maybe even 89, and I'll give you that 1 point. You know what I mean? So 85 is the mark on test averages. In order to pass the class. And of course, and that's considering you passed with 85, but then you did all your homework. I don't want to say you just passed with 85 and didn't do your homework, then that'll hurt you, but you got to do the homework as well. Yep.
Okay. Thank you.
All right, not a problem. So yeah, we'll pause right here. I hate to do it, but I think we'll be all right. So next class we'll do 2.2, 2.3, and 2.4. That'll kick us out of chapter 2, and then we'll be looking to do our administer our first test. Our first test may just be take home, but make sure you take advantage of that. Also, if I make it take home, and when I say by take home, in other words, there won't be a password in my math lab. You'll just be able to do it. Um, just make sure you do your scratch work, and then you send me a picture of your scratch work that comes along with that. And we'll go from there. Go from there. All right. Any questions, concerns, or comments before we dismiss for this week? All right, good, straight. All right. So you guys have a good one. Y'all get some rest, man. Y'all came in this thing tired. So get some rest, and I will see you guys next week. Have a great weekend. Have a great week. I'll talk to y'all next time.
I have a question.
Yes.
What advice would you give to someone who is good at math, like when it's fresh and it's in front of them? Because like everything that you say, like when you're explaining it makes sense. And like the homework, the ones that I've actually been able to finish, like I didn't have any problems with. But like I'm so scared to take a test because I'm just like, when I like go to take a math test, like it just like I don't remember how to do anything.
Yeah. So what the method to that, or the solution to that, really is just repetition. I know it's not the answer that a lot of people want to hear, but it's really repetition. It's just like whether it be football or basketball or whatever, they do things so much that it's not like they're thinking. So they go on the football field, they're not thinking about what they're doing, they're just responding to the situation. And math is like that as well, where you come in and you'll have one symbol that can alter what you do initially. Just like we were doing today. If we have, this right here. Oh, did it go through? I don't think it went through like I wanted to.
I
Yeah.
mean, I can see it.
Yeah. So we have 5x plus 3. Well, the first thing we'll do when we talk about next class is subtract 3 if I want to solve. But if I had parentheses, the first thing I would do is distribute. And so that's what really math, is. It's just pretty much doing it so much that it's not, I'm going into a test thinking about what I want to do. It's really reacting to the situation and the scenarios that are placed in front of you. So it's really about how much practice you have, how much time you have to put practice in. And for everybody, it's different. Wherein certain things, some people will get like that, but then they'll have to put in more time in other areas. And yeah, that's pretty much the only remedy that I know of, when it comes to that. Yeah. So just a little bit of practice. Got to put a little bit of practice time in. And know a lot of people don't want to mess with math like that. You know what I'm saying? So it might be challenging, but it's really about putting that extra practice time in.
No,
Yeah.
man, I got goals to meet. So
So that means you're gonna grind it out?
Just so I can dedicate more time to school. So
yeah. All
it'll be
right. So let me know if there's anything I can help you with, and most definitely I'm here for you.
All right. Well, thank you, sir. I appreciate it.
Not a problem. You have a good one. All right. Anybody else need anything? Everybody good?
I just needed to scroll back up to the beginning, but if you post the video between today and tomorrow, because sometimes I like to start my homework right after we do this, so it can be still fresh.
Yeah, that's the best way to.
Yeah,
that's the best way to do it. So this was the beginning of it.
I'll go back. When do you plan on posting it inside of our?
Since you asked, I'll try to do it tonight. Then I'll go ahead and post it tonight.
Okay, because then I usually do my homework at work, and I'll just sit and go over the beginning before I start my work.
All right, cool, not a problem. I'll make that happen for you.
All right, thank you.
All right, not a problem.
Bye.
All right.